Summer Physics 1-2. We're moving on to our next lesson, day 10, and this is on gravity. So what is gravity? Gravity is an attracting force between two or more objects. So you can think of it as a gravity, meaning that you grab onto something. So remember to think of gravity as gravity because you and someone you like, two people, want to grab each other. Now this is the classical definition from Isaac Newton many hundreds of years ago, and it requires two objects with mass to have a gravitational attraction. So a force of gravity exists between any two objects with mass. The force of gravity is referred to as gravitational attraction. There is a gravitational attraction between you and your pencil. The reason you don't feel it is because you and your pencil are small. So what determines the force of gravity? The force of gravity depends on two things. One, the mass of the objects. More mass means more gravity, and the distance between them. The more distance, the less gravity. So at least one of the objects has to be really large, like the Earth. You feel the Earth's gravitational pull because it's so large, but you don't feel the gravitational pull of your pencil because it's very small. The other is distance. You don't feel the gravitational pull of a star that's many, many light years, many billions and billions of miles away because it's so far away. So even though it might be a very large star, you don't feel it because of distance. What is weight? The force of gravity on an object is called its weight. Weight is measured in pounds here in the United States. When you stand on a bathroom scale, it gives you your weight in pounds. That's in the English system. The one we use, though, in physics is newtons. That's the metric system. And so weight is a force. Force is measured in newtons, and weight is a force. It's the force that you're putting on the Earth. It's also the force that the Earth is putting back on you. So what is the acceleration of gravity? If one object falls to Earth faster than another, it is because of air resistance, not gravity. Unless told otherwise, assume there is no air resistance when doing gravity acceleration problems. Gravity will pull objects with different masses to Earth at the same acceleration. And that acceleration is, we say it's 10 meters per second squared. Exactly, more precisely, it's 9.8 meters per second squared. But we usually use 10 in calculation problems because it's just a nice, simple, round number, and it's close enough to 9.8. Weight is the attractive force between an object and the Earth. It could be between an object and some other planet that it's on, but we're going to talk in terms of the Earth here. So to compute weight using the mass of an object, use the formula W equals mg, where W is the weight, m is the mass in kilograms, and g is the acceleration in meters per second squared. So you notice that follows the same form of F equals ma. If W weight is a force, and m is mass of the object, and g is acceleration, then that's F equals ma. That formula really is equivalent to F equals ma, but it applies specifically to the Earth's gravitational acceleration, and we call the force the weight. So what is Flora's weight on Earth if she has a mass of 45 kilograms? So W equals question mark. Mass is 45 kilograms. Gravitational acceleration of the Earth is 10 meters per second squared. So you use W equals mg, so that's 45 times 10 is 450 newtons. To convert between the metric measure of force in newtons and the English unit in pounds, you use the formula pounds times 4.5, 4.5 equals newtons, or newtons divided by 4.5 equals pounds. So Flora's weight in pounds is 450 newtons divided by 4.5, or 100 pounds. Gravity is the attractive force between two or more objects. The formula for the force of gravity between any two objects is force equals G times mass of the first object times mass of the second object divided by the distance between the two objects squared. So G is called the universal gravitational constant. You can see it's a very, very tiny number, and you should not confuse it with the small g that we just talked about in the last slide, which is G equals 10 meters per second squared. This is a different number. They both stand for gravity, both letters, but this is a different number altogether. M1 and M2 are the masses of the two objects, and D is the distance between the masses. So gravity is the attractive force between two or more objects. The formula for the force of gravity between any two objects is F equals G times M1 times M2 divided by the distance squared. So the key point to notice about this formula is that it requires two objects with mass to produce a gravitational attraction. Okay, and there's the formula down there you see in the illustration, the image there. Sometimes R is used instead of D for distance, but it's the same formula. So Albert Einstein developed a new understanding of gravity. Einstein said that bodies with mass curve the space around them. This causes objects to follow a curved path. Here's an image of that curved path, but it's just simply showing one layer of it. So that satellite could eventually follow a curved space path into the Earth. It would fall to the Earth, any object coming near the Earth. So there's really actually a whole matrix of those layers that you see there, and they all curve towards the Earth. We still, however, in this physics and in most basic physics, use Newton's definition. With Einstein's definition, there doesn't have to be two objects with mass. There just has to be one, and it curves the space. Newton says there has to be two objects. We still use that definition, even though technically scientists know that it's not correct, because it works. It works for almost everything in our everyday experience. But Einstein's definition is really believed to be technically more correct. All right, and that takes care of this brief lesson on gravity. We'll do a few brief projects on gravity before we move on.